As was mentioned, my name is Sarah, and I am at Boston Medical Center. And today I will be presenting the Health Equity Explorer tool, which is an R-Shiny application that allows us to explore pre-computed health outcomes by a variety of features about patients. So we created this tool, Dr. Bill Adams and I, in partnership with the Health Equity Accelerator at Boston Medical Center, and with a lot of support and feedback from the community advisory boards and a variety of really great epidemiologists and biostats people. So I'm excited to show you what we came up with. So currently you are looking at the real meat of the tool here. This is the Health Outcomes tab. And here we can see a pre-computed health outcome generated from the OMOP Common Data Model. And we can view that outcome over time. We have a library of health outcomes, as you can see here. Currently, we're looking at blood pressure control for patients with hypertension. This is just the CMS quality measure of a blood pressure value below 140/90 in a given year for a patient with hypertension. This percentage is the percentage of patients who meet that metric, so a higher percentage is better, and we can view that over time. This is interesting, but it gets a little bit more interesting when we can add some information about patients and break it down by different groups. So here you're looking at that same outcome broken down by races of patients. And you can see even just with this simple outcome, we can see that there are some differences between groups. And so we can see that visually. We can add in additional features about patients. We've got a whole library of features such as demographic information, food security and housing status, which is something that Boston Medical Center collects for every patient that visits the hospital. We have comorbidity and clinical data, and some exciting geospatial data as well, because as we know, people's health isn't just determined by the healthcare they receive, it's determined by quite a few other factors as well. So on this tab, we can add up to 2 variables. We can apply some filters to make this chart a little bit easier to read here. And then we can also view this in a table format with both the number of patients and then also the percentage of those patients meeting the health outcome. Because missingness is important as well, we can show that here too. And great, okay. Sometimes when I am doing a screen share, it gets a little bit slow. So we can visually see that there may be differences here, but it's important to check if there are actually statistically significant differences. So the goal of this tab here is to be able to explore your data in a little bit greater depth. You can look at the correlative structure of your variables. You can also look at the distribution of your data and then do some univariate modeling to look at the relationship between a particular variable and health outcome. The goal of this tab is to get to know your data a little bit better before you create a logistic regression model that has multiple variables, which you can do on this tab. So here you can add in as many variables as you would like to a logistic regression model for your outcome, and you can display it by your variable of choice. So here we're looking at a logistic regression model for patients with blood pressure below 140/90. That includes the variables of race, sex, and BMI. Here we're viewing this displayed by race, controlling for sex and BMI. And we can change the display. I just flipped it to probability of being in control for simplicity's sake, but you can look at this as log odds or odds as well. You can do some model analysis to check to see if there's anything weird going on. And you can play around with the model until you get something that is true and interesting. The last tab that I'll show here is our geospatial data tab. So here we have a couple of things that we can do. This is just the health outcome by neighborhood. This is the city of Boston, by the way. I know it looks kind of funky, but this is the city of Boston, and you can see the health outcome by neighborhood. You can pull in some third-party place-based data, like the social vulnerability index, socioeconomic index, to display them visually side by side. We'll give it a moment here. And then you can also, because this is great visually side by side, but you can also put them together and identify areas that are both severely impacted by social vulnerability, darker is worse, and also have fewer patients with controlled blood pressure. So those are these dark areas. You can also identify areas of bright spots, which might have high social vulnerability, but for some reason have more patients with controlled blood pressure. So we're interested in identifying not only areas of disparity where we could potentially change some interventions, but also areas of bright spots that we can learn from. So we envision this tool being used as kind of a prep to research tool. So being able to quickly load new outcomes and new variables, look at variables in ways you might not have thought of before, and then get aggregate results as a hypothesis generation tool, and just as a way for researchers and clinicians to pull in, geospatial data, clinical data, like a full, complete picture of a patient, and see how that impacts outcomes over time. So I think that is everything to show. And happy to take any questions. We also have a GitHub that I can direct people to with a video and more information as well.
Thank you so much, Sarah. Are there any questions? We do have time. I see one hand raised. Hayden, who I know you put something in the chat.
Hey, Sarah. This is amazing. My first question is, is this available? Is this could you put wherever we can get it in chat?
Yes. Yeah. Go ahead.
And then my second question is, I've been kind of looking at some of the data that you showed here, and some of the advantages of mixed effects over fixed effects models, and then also some looking into complex effects that can account for the between and within. How does this handle that type of those types of models? I think I saw a little bit of that, but I'm just wondering a little bit more about some of the models that have been put into this.
Yeah, so this is kind of like very, very early stages of development for this application. So we stuck with really, really basic logistic regression with a binary outcome of did you meet the metric in a year? The tool, since it's built in R Shiny, is that's one of the reasons why we chose to do that, is because it's a really flexible interface. So in future iterations, we want to expand model options, address those, within and between effects, and basically expand that as much as possible. So right now we have not addressed that, but that is definitely something we want to do in the future. Similarly with the geospatial part of it, that is super basic right now. There's a ton out there. Andrew Williams' group at Tufts is doing a lot of really great work with that information. So there's a lot of room to expand on this. But yes, the code is available on GitHub. We have both the outcome generation code, which you can change, you can edit, and then also the application code itself that you can also change and edit.
Wonderful. I think this would also be a really good maybe application of Shiny through the WebAssembly framework to get some of these models to run locally instead of needing to be server-based. Just kind of a thing that stuck out to me of having this type of a tool where it uses that. It's newer stuff, but I think really exciting for how we distribute studies and tools. So thank you.
Yeah, thank you. Yeah, we'd love to have people work with us and add modules to this. So please, if you're interested in that, send us an email and we can collaborate.
Andy, I saw you have a question in the chat. Do you want to just ask it?
You mentioned that you can modify the code on the outcomes. I just wondered about the concept sets that underlie each of the variables. Are those things that are editable by users, or that would be something, obviously, if we were going to customize it to a different OMOP implementation?
Yeah, so all of the code used to generate the outcomes is available. It's all just SQL based, but there's an R package that will run it against whatever your language is, your OMOP language is. So you can edit the SQL code before you generate the data model, and then have it be however you want it to be. Which I didn't really show, but there's a knowledge center and documentation and everything of how everything is put together as well. So there's lots of room to do whatever you need to do at your own site.
That's awesome. Great work.
Thanks.